did. So notes for today is block day, November 1 or 2, depending on what period you're in. But notes 4. So we're going to head toward being able to expand x plus y to the 8th without having to write out x plus y times x plus y times x plus y, etc., etc. But let's start with going the long way around on a couple of easy ones, right? I can FOIL that, hopefully without even having to write out, FOIL and show all the work. Like x times x is x squared, y times y is y squared, and then there's 2 xy terms. X plus y cubed is a little bit harder. X plus y times x plus y times x plus y. Right? Everybody knows it's not just x cubed plus y cubed. You can't do that. I've already FOILed 2 of them, so I already know what x plus y squared is because that was the previous problem. So I'm going to do x plus y times x squared plus 2xy plus y squared. Okay, so this just gets annoying, right? Distribute the x to everybody, distribute the y to everybody, collect all the like terms, and see what we get. So first the x is going to go to everybody. So x cubed plus 2x squared y plus xy squared. That's sending the x to everybody. If I send the y to everybody, I get plus x squared y plus 2xy squared plus y cubed. And then like terms, 1x cubed, and then x squared y, 2 of them plus 1 of them makes 3 of them, so 3x squared y. Then xy squared, 1 of them plus 2 of them makes 3 of them, 3xy squared plus y cubed. I mean, kind of a pain, but not awful. Just be careful and keep up with things. And you'd follow the same pattern if you wanted x plus y to the 4th and 5th and 6th and 7th and 8th. And it would basically be terrible to do it by hand. So that what we're headed toward is a shortcut for x plus y to the 8th. Like, that's the main point of today's lesson is, yes, that's awful, but the answer is going to be long and awful, but there's a better way to get to the answer than just multiplying it out 8 times and trying to keep up with things. Okay, here's some expansions of x plus y to the n. By the way, binomial theorem. Bi means 2, obviously, 2 terms. So this is a 2-term expansion theorem. That's kind of the shortcut. And then Pascal's triangle is even a shortcut to the shortcut. So there's the multiply it out method. We don't like that. That's what we just did. There's the shortcut method. That's the binomial theorem. And then Pascal's triangle is sort of the shortcut to the shortcut. And as always in math class, right, we teach you the long way first, because that's the way that has all the concepts and the theory in it. We want you to understand what's going on. And then we're like, hey, there's this kind of a shortcut. And then today we'll be like, and hey, there's even more of a shortcut. So we start out awful, and we get a little better, and then we get a lot better. So that's sort of the roadmap for today. Now, we did the awful one kind of on our own. And if we did even more awful, x plus y to the 4th and x plus y to the 5th, it would look like that. But we're not gonna take the time to do all that. Like, here's what it is. Just, trust me, if you wanna do it on your own, help yourself. So let's make some observations about the pattern here. So we're increasing the power by 1 each time. x plus y to the 0, 1, 2, 3, 4, 5. And so as we look at those, what patterns or what observations can you make? There's like 5 things written down, and there's probably 10 more things you could say. Michael, give me one of them.
The number of terms is the exponent plus 1.
Okay, I like that one. That's actually the first one written down over here. So the number of terms is 1 more than the exponent. Okay, well, if the exponent is n, then we can kind of shortcut that to say that the number of terms is n plus 1. So you're absolutely right. If n is 0, there's only 1 term. If n is 1, 2 terms, and so on. So yeah, the number of terms is 1 more than the power. Okay.
For each term, the exponents attached to x and y will equal exponent. So for the last one, for the fifth one, 5 for x to the fifth, and then x4 and x1, 1 is 5. 3 and 2, 2 and 3, 4, and 1 and 5.
Yes. So let's see how to say that. You're right. Like the exponents of the pieces add up to n. The exponents of x and y in any term sum to n. Right, so do you see what Cade was saying there? Like just pick any term you like. 10x cubed y squared. The exponents are 3 and 2, which add to 5. Or the exponents are 1 and 4, which add to 5. Or the exponent's just 5. So like the total exponent is always whatever n is. Good observation. Andrew, something else.
The exponent of x, y was 1 less than the exponent of the equation.
Say that again?
The exponent of x, y is always 1 less than the equation. Just add normal x, y.
The exponent of x, y.
The exponent of y, yeah.
Yeah, but not all the terms have an x, y. Like not all the expansions.
5xy is to the 4, and then 4xy is to the third. And then 3xy is to the second.
Okay, so can I phrase it this way? Like the coefficient of the second term is always n? That's one way to say it. That's not really what you were saying, but that's sort of where we're headed. The coefficient of the second term, let's see, the second coefficient,
And second to last.
good call, and second to last coefficient is always n. So 3 and 3, those are right next to each other. But even when we expand out to 5, the second coefficient and the second to last coefficient is always n. Yes. Something else. There's like 2 more things I want to say, even though there's probably more there to be seen. What about the powers of x as you move through the terms?
They go down and then go back up.
They're mirrored.
Well, the powers of x just go down,
Yeah.
and
then y.
and the powers of y go up. So let's see, the power of x, powers of x, start at n, right? They start at whatever the big power is, the 5 or the 4, whatever. Start at n and go down by 1. Until there aren't any left, right? X to the 5th, x to the 4th, x cubed, x squared, x, and no x's. That's sort of related to the fact that the number of terms is n plus 1. Right, because we started at 5 and we went down to 0, so that makes 6 terms. So these 2 statements are kind of related to each other. And then also related to that is the powers of y. Start at 0, right? There aren't any y's in the first term, and increase by 1. Until they get to n. And because one of them is going down and the other one's going up, that also means it's the same as, not the same as, it's related to the idea that their sum is always n. Right? One's going down, one's going up, so their sum stays the same. So those 4 statements are definitely related statements. All right, lastly, what about the coefficients? As you move left to right with the coefficients.
They double by n.
So like 5 to 10 doubles, but 4 to 6 doesn't double, so Okay, you may be looking for too much. We don't know yet like how you get from 1 to 5 to 10. But what about, like, look at all of those coefficients. 1, 5, 10, 10, 5, 1. 1, 4, 6, 4, 1. What's that? They mirror. That's a good word. I was going to use a fancier math word. Let's see. The coefficients. How should we say that? Mirror. We could say mirror. I'm going to include or add to that increase, then decrease. Right? Like the biggest term is in the middle, and the smallest terms are at the end. So they increase, then decrease, and I'll just say mirror. Like reflect, symmetric. All of those words kind of mean the same thing. 1, 5, 10, 10, 5, 1. 1, 4, 6, 4, 1. 1, 3, 3, 1. Okay, so there's clearly some patterns going on here. And in fact, we talked about expanding x plus y to the 8th. We're not going to do that yet, but I don't know where the coefficients would come from, but I could at the least get the powers right. Right? Because the x's would go down as the y's went up. And I don't know how to get the coefficients just yet. We don't have to go all the way. But you get the idea. So, like, at the very least, we know what the powers are doing. I don't know what the coefficients are doing just yet. Oh?
Okay, wouldn't the coefficients come from, like, 6 plus 4 and then the 4 plus 1 from the previous?
Oh, hold on. You're on to something, but I skipped over. I would know what this power would, or what this coefficient would be. That's one of the patterns you picked up on. That would be 8. Sorry, Owen, what were you saying?
Like, I was saying the previous one, like 4 plus 1 would give you the 5, and then the 6 plus 4. I mean, yeah.
Uh-huh. Yeah. That's the shortcut to the shortcut. You're skipping too far ahead. But that's okay. You're right. That is part of the pattern. And that's Pascal's triangle. That's what we'll get to toward the end. So good catch. Kind of hoping you wouldn't see that yet. But no, it's a great catch because that's exactly what's going on. Although that means if you want to get to the 8th, you can't really jump straight to the 8th unless you have all of the previous, right? This is sort of that recursive versus explicit formula thing. Like, that's a great recursive way to get there, but I can't jump straight to the 8th unless I know an explicit way to jump to the 8th. So you're right, it's a good observation. There is this like adding thing going on to get those coefficients, but I can't get the 8th unless I know the 7th, and I don't know the 7th unless I know the 6th, and I don't know the 6th, and so on. So the triangle, some of you found it, or you saw it on the back of I think it's on the back of the worksheet. And I'm just giving away all my answers here. On the back of the worksheet packet, let me just jump to the end since someone picked up on it. That's what those numbers are. Like there's 1, 5, 10, 10, 5, 1. And there's our row 8. 1, 8, 28, 56, 70. That's Pascal's triangle. So he picked up on that pattern that you saw. But before we get to that, let's figure out like the explicit way to get to any particular term we want to. All right, the coefficients of a binomial expansion. And a binomial expansion, that's when you have x plus y to the n and you expand it out, right? Like that's a binomial, that's an expansion. So the coefficients are called the binomial coefficients, that makes sense. And to find them, we can use the binomial theorem. Okay, so remember this, the binomial theorem is like the first level shortcut. Right? Rather than multiplying everything out, we can use the binomial theorem. The second level shortcut, the ohm shortcut, is the add the triangle thing. We'll get there in a minute. Okay, in the expansion of x plus y to the n, you can see some of the stuff that we already knew, like x to the n. Like look at the x's. X to the n minus 1. And then toward the end, there's an x, and then there's no x's. The x's are going down. If you look at the y's, there aren't any y's, and then there's a y to the first, and a y to the second, and a y to the third, and then toward the end, you're one short of the whole thing, and then y to the end. So the power stuff, we picked up on that pattern. We also got that n, the power, is that second coefficient we got there. What we don't know yet is this thing in the middle. Like, what is this supposed to mean? C with a little n in front and a little r at the end. Like I don't even know the right word. A pre-subscript and a post-subscript. Two subscripts, one on the front end, one on the back end. Okay, well here's the definition of what that is. So the front number is n factorial, remember n being the power. So the power factorial is in the top. And then the bottom number is n minus r factorial and r factorial. The tricky part, I guess, is that r corresponds with the power of y. That's the r corresponds with the power of y. So n is the overall power. And r is the y power, the power on y. Okay, so let's say that we're in our x plus y to the 8th term, the expansion that we looked at earlier. Somewhere in the middle there's an x to the 5th y cubed. Right? Like, there's a whole bunch of other terms, but somewhere there's an x to the 5th y cubed term. You believe that? Because they add to 8. The coefficient of that is that c. 8 is the overall power, and the power of y is the second number. And so that means the coefficient is 8 factorial over 5 factorial, 3 factorial. We're going to get practice on this. I know this is weird. Once we get there, there's going to be lots of patterns that you see.
So you're just putting the C over the other stuff?
So it ends up being, the C and the N's and the R's is more complicated. It's the total power over the x power factorial, y power factorial. Maybe that's the easiest way to say it. Yes, with factorials on them, but yes.
But they're excited.
That's perfect. It's the overall power over the individual powers, and everybody's excited to be there. Right? Just like you coming to pre-cal class. You walk in with an exclamation point after your name every day.
For sure.
Yes.
I get it now.
Okay, now, so this is one of those, like, it's easier to do than it is to explain, because we started explaining it with the C's and this notation of n over r, but you don't have to worry about that.
It doesn't matter if you do
Wait, what is the exclamation marks gonna get?
Factorial. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1.
So you just go.
But it doesn't matter if you do it to 1, because whatever you multiply by 1 is just that.
That's true. You can stop at 2 and be okay.
Oh. Alright.
Yep. It's exciting. That's what it is. Okay, so can we do some examples? Yes, that's a great idea. So in the expansion of x plus y to the 8th, the first term is x to the 8th. Like, we know that already. And we even know the coefficient of that term, right? Like, if you did x plus y 8 times, if you multiplied all the x's, you'd have 1x to the 8th. Now, according to this formula, the coefficient, we already know the coefficient is 1, but according to this formula, it's the total power, see if I can write it out how Dia said it, total power factorial over the x power factorial times the y power factorial.
That makes more sense.
Good job, Dia. You explained it for everybody.
But does it always work like that?
It does. It's always that. It's always the total power. So that top number is always 8, at least for the expansion of 8. And then the bottom one is going to be changing because we know the x power is going down, 8, 7, 6, 5, 4, as the y power is going up, 0, 1, 2, 3, 4, 5.
Wait, are the x and y powers being multiplied?
Their factorials are being multiplied. And then this one's kind of dumb because, like, why would you already knew it's 1. 8 factorial over 8 factorial. Even if you don't know what 8 factorial is, you know that those cancel to 1. And do you remember what 0 factorial was defined to be? 1. And this is why 0 factorial is defined to be 1, so that this rule works for the first term. Because if 0 factorial is anything else, we'd need a different rule for the first term. It's like, let's just make the rule work all the time. And in order to do that, this seems a little fishy, but let's just say 0 factorial is 1. And then our little shortcut rule works all the time. The second term. Okay, so x is going down in power. Y is going up in power. So it's still the total power factorial over x power factorial, y power factorial. And we did some of these reducing. 8 factorial is 8 times 7 times 6 times 5. 7 factorial is 7 times 6 times... And so just 8. And the 1 factorial is there too, but that's just 1. So that coefficient is 8. But we knew that one already. Right? The first coefficient's always 1. The second coefficient's always the power. After that, things get a little bit weird. Like the third term. So I don't know what the third term is. Well, I do know what the powers are. 8, 7, 6, 0, 1, 2 for x and y powers. Right? So the x's are going down, the y's are going up. And then that coefficient, this is going to take a little bit more work here. 8 times 7 times 6 factorial over 6 factorial, 2 factorial. I wrote them sort of offset. kind of emphasize that the 6 factorials will cancel. So 56 divided by 2 is 28. It's very much a pattern, and once you get the pattern, it's like, oh, this is weird, but it's not that bad, because I know what the x's are doing, I know what the y's are doing, and now I know how to get the coefficients. The coefficient's a little bit weirder, but I know how to get the coefficients. Find the coefficients of the term x to the 5th y cubed. Well, like the shortcut is easy. It's the total power factorial over the individual power factorials. So 5 factorial and 3 factorial. That takes a little bit more work. 8 times 7 times 6 times 5 factorial. So there goes the 5s, or 5 and down. And then 3 factorial is 321, which is the same as 6. So yeah, I can cross out 3, 2, 1, and 6, and I get 56. So that's the coefficient of x to the 5th y cubed. Why don't I press pause and you find the coefficient of x to the 4th y to the 4th? You got this. So the 3 and the 2 make 6, so that can cancel. And then the 8 and the 4 can reduce to a 2 in the top. So be careful about, who's gone and who's left. But it looks like I have a 2, a 7, and a 5. 2 times 5 is 10. Times 7 is 70. So the coefficient of x4, y4 would be 70. Okay, so write the full expansion of x plus y to the 8th. Okay, I don't do this term by term. I do the x's, and then I do the y's, and then I do the coefficients. So it's gonna be spaced out, and it may not end up looking right when I'm done, because I know that the x's start at x to the 8th and go down. And I'm leaving lots of space because I don't know what the y's and the... trying to fill up the whole page here. So the x's go down to 0. The y's go up. Be careful though. How many y's are on the first term? 0. None of them. And then they start. So y to the 1st goes with x to the 7th, and then y squared and y cubed and so on. Alright, we know let me pause there. So I got my x's and my y's situated. The x's are going down, the y's are going up, and they always add to 8. So I feel pretty good about those. Now the coefficients, we know the first one's 1. We know the second one is 8. We don't have to do anything there. We found the third term a minute ago. That was 28. So I can just borrow my 28 and put him right there. We also just did x to the 5th y cubed. That's 56. And we did x to the 4th y to the 4th. That was 70. Uh-oh, I didn't find there's 4 more terms there.
You can do the mirrors.
But they mirror, they reflect. So if you're counting, you can keep up with when it starts to go down. It might be better to just start at the other end and know that that last term's got to be 1. And the second last term has got to be 8, and then sort of mirror that way. So the next one's 28 because we're mirroring, and then the next one is 56, and 70 doesn't have a mirror, but that's because it's the one right in the middle. So the ones that don't have a middle, that don't have a 4 and 4, it still mirrors. Like look at the previous page at x plus y to the 5th. There's 2 10s in there. So it's still a mirror situation. So it depends on if you have an exactly in the middle term or not. Okay, x's count down, y's count up, and then there's the weird crazy thing for the coefficient. But I still claim that's way, 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 way better than doing x plus y to the 8th, x plus y times x plus y times x plus y times x plus y. Right? Maybe that could have been our warm-up for the lesson. Is here, do x plus y to the 8th longhand, and then you would have an even better appreciation for the shortcut. All right, some more problems. In the expansion of x plus y to the 7th, what is the coefficient of the x to the 4th y cubed term? Dia, tell me what goes where.
Okay, so the 7 factorial is on top.
Yep.
It's over 4 factorial and 3 factorial.
Yeah, that's it. So don't get lost in the NCR thing and the N over R with parentheses but not a fraction bar. Yeah, it's just 7 factorial over 4 and 3 factorial. And so then, yeah, you got to kind of figure out how to get there. But this one's not bad. Like, one of the factorials will always cancel out. And then you play with what's left, and it'll always cancel out. It just may take some work. So what's left is 35. So the coefficient is 35. Okay, so this is a pretty wild shortcut. You think about how hard it would be to get x plus y to the 7th and how long that would take. And we just jumped to this. We knew this would be a term because the powers add to 7. And there's this little trick to figure out what the coefficient is. So it's a little bit wacky, but it's still way, way better than going longhand. All right. Let's take it up a little bit here. In the expansion of 2x minus 3 to the 5th, what is the coefficient of the x cubed term? Well, they didn't. Interesting. So let's figure out what the x cubed term is first. It wouldn't have just been x cubed, it would have been 2x cubed, right? Because you would cube the whole first thing, which would be 8x cubed, but hold on to, you're right, hold that thought though, because I got to cube all of 2x. And the powers have to add to 5, so something's getting squared. What is getting squared? The negative 3, good, because that's the second piece. And then the coefficient, at least sort of the shortcut coefficient, is 5, that's the big one. And then the two pieces are 3 and 2. So got to kind of put all of that stuff together now. So let's see, 5 times 4 times 3 factorial. So that would be 10. And then times 8x cubed times positive 9. 10 times 8x cubed times 9.
Why did you do it times 8x cubed?
I cubed the 2x.
Oh.
So cube the 2 and cube the x. 9 times 8, 72, times 10 is 720. So that term would be 720x cubed. I guess that means our answer then, the coefficient is 720. number 3. In the expansion of that thing, x squared minus 2 to the 10th, what is the coefficient of the x to the 14th term? Okay, so I'm going to have x squared to some power, negative 2 to some power, and then 10 factorial over those two powers, whatever they are. This is a little bit tricky here.
Would it be x squared to the 14th?
Well, I want my answer to have x to the 14th in it.
7.
So that needs to be a 7 right there in order to get the x to the 14th. Which means what's the other one? 3. So what are the two numbers in the denominator of this factorial thing out here? 7 and 3. Or the excited 7 and the excited 3. Okay, the hardest part's done. Now I've got to clean this up. So 10 times 9 times 8 times 7 factorial. And then 3 times 2, so I got to figure out who 3 and 2 can reduce with, but 9 and 3 can reduce to 3, and then I can reduce the 2 with the 8 or the 10, either way. So that's 3 times 4 is 12, times 10 is 120. But be careful, I'm not through yet because I still have negative 2 to the negative 2 cubed. Should be negative 8. So I need to do 120 times 8. 960. And don't forget the negative. So negative 960 x to the 14th is the term. The coefficient would be negative 960. Okay, so if we're asked for an individual term, usually we use the binomial theorem, because that way you can zoom right in, pick out one term. It's the overall power over the two powers, all with the factorials. And then you have to be extra careful if it's not just x and y. You got to be careful to make sure you cube, or fourth or fifth or whatever, all of the terms. So the 2x or the negative 3 or the x squared or the negative 2. Now, if the entire expansion is asked for, it's often easier to use Pascal's triangle, which if Ohm had discovered it first, it'd be known as Ohm's triangle. Sorry, Pascal beat you to it. To determine the coefficients, rather than to painstakingly find each individual coefficient. So if you arrange the coefficients of, let's kind of go back to where we started here. We started with x plus y to the 0, that would be 1. X plus y to the first, that's really easy. That's just x plus y. But I'm only writing the coefficients. I'm not doing the x's and the y's, because the x's and the y's are easy, right? Start with the highest power, go down for the x's, start with 0 y's, and work your way up. X plus y squared, we said, was x squared plus 2xy plus y squared. Cubed is 1331. And then the triangle thing is exactly what you noticed earlier. I mean, you always know the first two terms. It's 1 and the power. After that, you can start doing the sum of the two above it. 3 plus 3 is 6. 3 plus 1 is 4. And 1 at the end. And at some point we could just stop writing x plus y to the power, because we know what the power is, because that second coefficient tells us what power we're on. 1 plus 4 is 5. And so on. guess keep going until you run out of space. I don't know. We're going to stop at 7, but you get the idea. You can keep going as long as you like. So Pascal discovered that first, so he gets to name the triangle. You've probably heard Pascal's name before, right? What's the unit of... You guys are in physics right now, aren't you, most of you? What's the unit of pressure? Pascals, or maybe kPa, which is kilopascals, because a pascal is not much pressure. So he's definitely big in physics. He's big in math. He's got published stuff on philosophy and philosophy of religion. Like, this guy is
Wasn't his wager like
a
this?
Renaissance man.
Like, an atheist has everything's blues if God is real, and a Christian has nothing's blues. Was that his wager?
Yep. And if you're curious on one of his more famous religion/philosophy musings, thoughts, it's called Pascal's Wager. And it's too close to religion for me to dive into, but it's interesting if you're curious about religion, philosophy kind of things. All that to say, Pascal, quite the dude. All right, determine the expansion of that thing. Okay, the expansion means all the terms. So I'm looking for my worksheet because I know my worksheet packet has the full triangle all the way to the 20th row on the pack. Goodness, I can't even read those numbers. Are my eyes bad, or are those illegible at the very bottom?
960.
107960? Whew. Well, we don't have to go that far for the fifth one. So, for the fifth one, be careful about saying which row you're on, because the fifth row is kind of the sixth row. So be careful because you started with 0. We had this problem with sequences and series. Like if you started 0, what's your count? But if we're going to the fifth, we know we're using the one that has the 5 in it. So from the triangle, my coefficients are 1, 5, 10, 10, 5, 1. And I'm writing them way spread out because I know there's more work to be done here. A lot more work to be done. So the first term has the first term to the fifth and none of the second term. Again, I like to fill them all in at once, though. So I'm going to take my first term and fill all of those in. So 1 over x to the fourth, 1 over x to the third, 1 over x squared, 1 over x, and then nothing on that last term. And then the second term is negative 2y, so make sure you grab all of it. How many negative 2y's are in the first term? None of them, right? So be careful. Make sure you start at the right spot. So negative 2y to the first, and then negative 2y squared, and negative 2y cubed. By the way, you can always start with a plus in there. You can always just assume it's plus. And then when negatives show up, they will change the signs of some of them. But just assume it's a plus to start with, and let the negatives fix it kind of as you go. Negative 2y to the fourth, negative 2y to the fifth. So that's Pascal's triangle. That's the shortcut to the shortcut. So that means we just multiplied out this thing to the fifth, and we did it pretty quick. Now, we're not done yet. We need to clean it up. So this would be 1 over x to the fifth minus, let's see, how much can we do at once here? 2 times 5 is 10, y over x to the fourth, plus, my denominator will definitely be x cubed. My numerator would be 4 times 10 is 40. Then negative cubed, so my next term will be minus. My denominator will be x squared. 2 cubed is 8. 8 times 10 is 80. plus, denominator's x. Negative 2 to the 4th is 16. 16 times 5 is 80. And then lastly, oh, wait a minute. I was leaving off some key things there. The y's. Yes. So focused on getting 2 squared right. Forgot that's y squared and y cubed and y to the 4th. And the reason I missed it is, or the reason I caught it, is at the end I knew it was going to be 32 y to the 5th, and then I realized I was missing all my y's. This 32? Because I'm fifthing the negative 2 and fifthing the y. An important note here to be careful about. At this stage, all my coefficients mirrored each other, 1, 5, 10, 10, 5, 1. But once we threw in the numbers and cubed them and squared them and fourthed them and combined everything, my final coefficients aren't necessarily mirrored. Okay? So be careful. Initially, yes, they're mirrored, but once you simplify things, there may be some sort of pattern in there, but it's not necessarily going to be mirrored. Difference quotient. Difference quotient. Let's see. That's f of x plus h minus f of x all over h. That was not y'all's bonus. Yeah, y'all had the cost of the paint can thing. Other classes had different quotient as a bonus, which would be a lot easier now because we know how to expand x cubed. So f of x plus h would mean 4 times x plus h cubed minus 4x cubed all over h. And so now for the fun part, x plus h cubed, but we have a shortcut for that. The coefficients for the cubic row, again, we gave you your nice 1, 3, 3, 1. So I'm going to put those in first. And then my x's will go start at cubed and go down to nothing. And my h's will start at 0 and go up. If you're worried about where to start the h, you can also start at the far end and know that the last term will have h cubed on it. And so work your way down. You can do it that way. And then minus 4x cubed all over h. Okay, home free now. Distribute the 4. So 4x cubed plus 12x squared h plus 12xh squared plus 4h cubed minus 4x cubed all over h. Anything we can do there?
Get rid of them. Cancel out the 4x.
Cancel out the 4x cubed.
Just get rid of the h from each term.
And then the h will divide into each term. So 12x squared plus 12xh plus 4h squared. Find the difference quotient of x to the 6th. F of x plus h minus f of x all over h. So that's x plus h to the 6th minus x to the 6th all over h. Well, normally this would be terrible. It's still not, like, I don't know, it's not difficult. It's just kind of annoying. So I go to my triangle, and I want the row with the 6 in it. I'm careful not to say the 6th row because it depends on how you're counting, but the row with the 6 in it. 1, 6, 15, 20, 15, 6, 1. And then don't forget there'll be a minus x squared, or x to the 6 at the end. And again, you can build it term by term, but I like doing all the x's and then all the h's. X to the 6, x to the 5th, x to the 4th, x cubed, x squared, x, and nothing. They're all added because there weren't any negative signs to worry about. No h's on the first term. I feel like I'm trying to emphasize that. That's a kind of a common mistake, is if you put an h on the first term and then an h squared on the second term, then they're all wrong. But if you remember that they all have to add to 6, that will help. So my h's are counting up now. Yeah, my x's are going down, my h's are going up. All the powers, each term, the powers add to 6. Once again, the x to the 6 will cancel. And once again, everybody has an h in it that can be canceled. 6x to the 5th, 15x to the 4th h, plus 20x cubed h squared, 15x squared h cubed, 6x h to the 4th, plus h to the 5th. Ugh. So a lot of terms and a medium amount of work, but before Pascal or before the binomial theorem, this would have taken forever. Not forever, but it could have been done. It just would have been really annoying. Determine the expansion of 1 minus I to the 7th. Okay, so to the 7th means I'm going to go to my triangle, and I'm going to try to spread them out as much as possible. 1, 7, 21, 35, 35. And I know it's mirrored now, so 21, 7, 1. So start with the 1s. They start at the power of 7 and go down. That's all 1. So if you're really thinking ahead, you're like, wait a minute, am I really going to write 1 to the 7th and 1 to the 6th and 1 to the 5th and 1 to the 4th and 1 cubed and 1 squared and 1? You don't have to. I'm going to, because I want to continue to see the power, or the pattern, as I almost mess it up. As I did mess it up. 7, 6, 5, 4, 3, 2, 1, and none of them. But again, it doesn't matter because it's 1 to the power. What's more important is the I stuff. So there aren't any i's on the first one. Negative I on the second one. Negative I squared. Negative I cubed. I should have left the 1s off because they're messing me up here. Negative I to the 4th. Negative I to the 5th. Negative I to the 6th. And negative I to the 7th. Okay, so it starts out easy, right? 1, and then minus 7i. What's I squared equal to? Or excuse me, what's negative I squared equal to? That would be 1. So plus 21. plus, oh, I don't know if it's plus or not. 35, negative I cubed. So the negative puts a negative out. What's I cubed?
Negative 1.
No,
I1, negative I.
Negative I. I cubed is,
And if you make it in a negative I is
it's
positive I.
positive I. Yes.
I is negative in the first place, and then if you're cubing it, then it's the whole I1, I1.
Yeah. Maybe I should have sort of reviewed that down here. Back to this one though. Back to my 21. Right? If I square the negative, I get a positive. If I square I get negative. So I think this is that minus 21? I think that's minus 21. Negative I to the fourth. Okay, well, negative to the fourth is positive. I to the fourth is 1, so that one's plus 35. There is a little bit of a pattern developing, I think. 1, negative I to the fifth. So again, that's negative 1 to the fifth and I to the fifth. So I to the fifth is I, but negative 1 to the fifth is negative, so negative I. I to the sixth would be negative 1, so minus 7. Thank you. And then that last one, so negative 1 to the seventh is negative. I to the seventh, I'm back over here on my pattern, which you can't see now. 1, 2, 3, 4, 5, 6, 7. I to the seventh is negative I. So negative 1 times negative I is plus I. Yeah. So there is a pattern. The pattern got a little weird on this. Positive and then negative, negative, positive, positive, negative, negative. Positive. Okay, combine all my like terms. 1 minus 21 is negative 20. Plus 35 is 15. Minus 7 is 8. Negative 7i plus 35i is 28i. Minus 21i is 7i. Plus I is plus 8i. What a lovely little problem that was. I want to verify that I got that right.
I think 21, the first 21 is positive.
You think that one's positive? So it's negative 1 squared times I squared, right?
Yeah, I know.
So negative 1 squared is positive 1, but I squared is negative 1.
And negative 1 times negative 1 is positive 1.
Because it's a negative I.
I have a way to check it. Your calculator can do math with I. 1 minus I is the period, second decimal point. Yeah, this is the moment of truth. Oh, I got it right. Why did it do that? Because I don't... Oh, it did do it. I thought you had to be in A plus BI mode to do that, but... Why didn't we do that at the beginning? Because we didn't have a calculator at the beginning. I had to reach down here to get my calculator. I didn't want to do that. I would much rather like work it all out than reach all the way down there and grab my calculator and
Really?
work on it. Yeah.
When's our test?
Your test is... What worksheet are we on? Number 4?
Yeah.
Worksheet 4 is today's assignment. Your test, let me see if that's right. Verify. Test is next week on 2 days, or over 2 days.
I think it's
like Monday, Tuesday.
Wednesday and Thursday off on Wednesday.
Friday is more like Pascal's day 2. There's some other fun, weird, interesting patterns and things that go on with Pascal's triangle, which is why we're through with the notes packet. So on Friday we'll work some of the worksheet together and call it a day. I do have another worksheet to give you, a review worksheet, and then the test will be next Wednesday, Thursday.